Alright everybody, so this first video is just me going over 4 of the harder homework problems from part 1 of the lesson from Tuesday or Wednesday. I just picked these because I think they're the ones that kind of cover all the material. So this is going to be a short video, just a few minutes per problem, but if you found yourself struggling on some of these, then this video is for you. If you got all the homework problems done, no problem, and are ready to move on, then you can move on to video number 2 and you can watch those and be good to go. So let me start here with number 33. Okay, my cat is sitting in my lap right now, so if you see him pop up, he's just glad that I'm working from home today. So we look at this equation and we've got 3 secant squared minus 4 equals 0. That's one trig term, so I need to isolate it. So I'm going to add 4 and divide by 3 and get to this point. And now I notice that this is a secant squared. I'd much rather it be a cosine squared, which is the reciprocal. So let's flip this to cosine squared and also flip this so that now we are a couple steps away from solving. We need to solve for x. So I'm going to square root this, square root this. So the square root of cosine squared is cosine, and the square root of 3 over the square root of 4 is plus or minus the square root of 3 over 2. So voila, we are now ready for the unit circle to take over. And since I have a plus or minus, I know that I'm going to have 4 solutions. So when is cosine? What angles of cosine give me root 3 over 2? That's going to be 30-degree reference angle, so pi over 6. So it's going to be all of the radian values that have a 6 in the denominator. So we'll have quadrant 1 pi over 6, quadrant 2 5 pi over 6, quadrant 3 7 pi over 6, and quadrant 4 11 pi over 6. And those are our solutions. That's number 33. Okay, moving on to 43. 43 has multiple trig terms, and we've got to factor here. So I'm going to move this term over to that side. So what am I going to get? I'm going to get sine times cosine minus 3 cosine equals 0. I need to factor out a GCF. They both share a cosine, so I'm going to factor out the cosine here. So now that I did this, I can now set each part equal to 0. I can set cosine of x equal to 0 and solve, and I can set sine of x minus 3 equal to 0 and solve. So when is cosine 0? That's going to give me 2 answers. That's going to be, let's see, cosine is 0 at 90, which then it means it's also 0 at 270. So there's 2 of my solutions. And then this second part, sine of x minus 3 equals 0, that simplifies to sine of x equals 3. That's not on my unit circle. Sine never equals 3. It equals square root of 3 over 2, but that's a totally different thing. So this is not going to give me any solutions. If it's not something that we're used to solving on the unit circle, then it just doesn't give me solutions. So this one only has 2. So there's 43. 2 more. 45. This one's tricky. So let's see. This jumps out at me, the cosecant. I'm going to probably change that. So I'm going to start by doing that actually. I'm going to say 2 sine of x plus 1 over sine of x equals 0. I'll put this over 1 just to keep it balanced. And I think we need to do a least common denominator here. I think that's going to be the only way. So I'm going to multiply this by sine over sine. So I'm going to get 2 sine squared plus 1 over sine. Interesting. We're trying to solve, so I need to get sine by itself. So if I multiply this by sine of x to cancel, I can multiply this by sine of x, and that that just turns to 0. So I'm at 2 sine squared plus 1 equals 0. So now I'm down to more of like a problem that we did earlier in the homework. But look what happens. When I start solving this, subtract the 1 over and divide by 2, I get to this point, and I need to square root this sine squared x to get sine. But then I end up square rooting a negative over here, which gives me an imaginary number. We don't like imaginary numbers. We don't use them. We're looking for real solutions only. And so this is going to end up being no solution. The fact that you see a square root of a negative means there are no real solutions to be had in this problem. Took us a minute to get there. The answer is no solution. And then last one. This is a great one. If you did well on the proofs test, then I'm hoping that you made a connection here. And that was that these are two different trig terms, and we need them to be the same. So what if I use identity number 8 to switch this out for a tangent squared plus 1? I totally switched the secant squared out for a tangent squared plus 1. And then I still have this tangent squared, and I still have this minus 1. That's still part of the problem. And then what does this do for me? Now it's all in form of tangent, so I can look for like terms. The tangent squared and the tangent squared makes 2 tangent squared. And the plus 1 and the minus 1, those cancel. So I'm actually here, and I'm ready to solve. Divide both sides by 2. Square root both sides. And when is tangent 0? Tangent would be 0 at 0 and at pi and at 2 pi. But I think the homework told us to do this. It told us to give us all solutions between 0 and 2 pi, and it didn't tell us to include 2 pi. It only said less than. So technically we wouldn't need this. Technically this is enough. But if you did include 2 pi, then that's okay. Because remember, all of our solutions need to fit this domain range here. So that problem took an identity up here in the beginning, and then we used algebra the rest of the way. So I hope this was helpful. I was able to check in with you at the end of class on Tuesday and Wednesday, but for some of you who weren't here, hopefully this is helpful. And for those of you who were here, maybe this is a good refresher to start the day, because today we're going to add a little different spin to it. So skip now to videos 2, and then for the new material, video 3. And good luck. Bring any questions that you have with you next week.